So today we are studying chapter number 8. Oh, earlier we have studied chapter number 8 where we are studying chapter number 9. Uh, it is called atmospheric circulation and weather system, weather weather systems. Let's start. Earlier chapter 8 described the uneven distribution of temperature over the surface of Earth. Air expands when heated and get compressed when cooled. This results in variation in atmospheric pressure. The result is that it causes the movement of air from high pressure to low pressure, setting the air in motion. You already know the air in horizontal motion is wind. Atmospheric pressure also determines when air will rise or sink. The, the wind is redistribution. The wind redistributes the heat and atmosphere across the planet, thereby maintaining a constant temperature for the planet as a whole. The vertical rising of moist, moist air cools it down to form the cloud and bring precipitation. This chapter has been devoted to explain the cause of pressure difference, the force that controls atmospheric circulation, the turbulent patterns of wind, the formation of air masses, the disturbed weather when air masses interact with each other, and the phenomena of violent tropical storm. So let's go. Just let's go through the structure of the chapter. So first of all, we have to read the atmospheric pressure. Uh, about atmospheric pressure, then vertical variation of pressure, vertical variation of pressure, then after that it's horizontal distribution of pressure. Now, this is variation and this is distribution, so this is a whole new different topic. Small difference in pressure are highly different. Okay, world distribution of sea level pressure, so there's a different pressure at the sea level. This is all the diagrams, and the next one is force affecting the velocity and the wind direction of wind. So we'll read about the force which is affecting the velocity and the direction of wind. So now the first one is the pressure gradient force, frictional force, Coriolis, Coriolis. Okay, Coriolis force. I think we have read something about Coriolis force in previous chapters. Uh, and pressure and wind, cyclonic circulation, general circulation of the atmosphere, general atmospheric circulation and its effects on ocean. Since this is in the box, this automatically becomes important for exam. Next is seasonal wind, local wind, land and sea breeze, air masses. So pretty much this is fronts, uh, extratropical cyclone, tropical cyclone originate, intensifies, and that's pretty much it. Thunderstorm and tornadoes. So this chapter is kind of interesting because it has tornado and all. So let's get started. The first one is atmospheric pressure. Do you realize that our body is subjected to a lot of air pressure? As one moves up the air, as one moves up, the air get verified and one feel breathless. The weight of the column of the weight of a column of air contained in a unit area from the mean sea level to the top of atmosphere is called atmospheric pressure. Basically, it's saying from the sea level, if we go up, so we are taking sea level as a base. Like this is the sea level, and as we go up, we'll get some kind of pressure. If we are here, we'll feel some kind of pressure. The weight of the column of air contained in a unit area from the mean sea level to the top of atmosphere is called atmospheric pressure. So the pressure with what we'll feel here will be different from the pressure what we'll feel here, since the air is much denser in this area. Hence we will feel more air pressure. More air pressure means more oxygen. More oxygen in per unit area of air. Okay, in this one. And the same since as we go up, the atmospheric pressure decreases, and the oxygen per unit area will be less less will be less. Hence, when we go when we go in higher altitudes, uh, getting dizziness is very common, especially when our body is not if our body doesn't get adapted to high altitude places. That's why when people go to Ladakh and all, because they're, it is on high altitude, it is mandatory for them to stay like 2 or 3 days to stay there, to for their body to get accumulated, like to get adapted to the pressure there. Otherwise, they will get sickness, and they won't be able to do their Ladakh trip at all. So, okay, let's go back to the chapter. Uh, One may feel breathless. Okay, this is the atmosphere. The atmospheric pressure is expressed in the unit of millibar. Atmospheric pressure is atmospheric pressure expressed in unit of millibar. At sea level, the average atmospheric pressure is at sea level. Let's mark this. This is a sea level. The atmospheric pressure, average atmospheric pressure is 1013.2 millibars. Due to the gravity of air at the surface, Due to gravity, the air at the surface is denser. Okay, as I explained before, hence the higher pressure. Air pressure is measured with the help of mercury barometer or aneroid, not android. This is aneroid barometer. Consult your book, practical book of geography part 1. Learn about the relationship in the pressure. Pressure decreases with height, so the pressure decreases at height. At elevation, it varies from place to place, and its variation is primary cause of air motion. Wind which moves at higher pressure area to low pressure area. That is okay. Vertical variation of pressure in the lower atmosphere. Let's change the color. Vertical variation of pressure in lower atmosphere. The pressure decreases rapidly with height. In lower atmosphere, like where the atmosphere is less, the pressure decreases as we go up vertically up. The pressure decreases rapidly with height. The decrease amounts to about 1 millibar for every 10 meter increase in elevation. So let's mark this in green. 1 millibar for every 10. Uh, it does not always decreases at the same rate. Table 9.1 gives the average pressure and temperature at the selected level of elevation for standard atmosphere. Standard pressure and temperature for selected levels. At sea level, that is 1000. This is millibar. This is yes, 1013.25 millibars. That is if the temperature is 15.2 degrees Celsius, and from 1 kilometer from that sea level is 898.76. The temperature also decreases as we go up vertically up. And now 5 kilometers from the sea level is the pressure is about 540.48. The temperature is minus 17.3. And again, after we are 10 kilometer high, the pressure in the atmosphere is 265, and the temperature is almost 50 minus 50 degrees Celsius. That is 49 point to be precise, 49.7. The vertical pressure gradient force is much larger. The vertical gradient, the vertical gradient pressure gradient, the vertical pressure gradient force is much larger than the horizontal pressure gradient, but it is generally balanced by a nearly equal but opposite gravitational force. Hence, we do not experience upward wind. Okay, it is saying as we go up, due to gravitational force, due to gravitational force, like it balances out the pressure that we will feel when we go vertical upwards, like change in the pressure. So the horizontal distribution of pressure. Small difference in pressure are highly significant in terms of the wind direction. Small differences in pressure are highly significant in terms of wind direction. So the where the pressure is higher, they will basically where the pressure is higher, they will kind of suck the air, right? Like they will attract the air from the lower pressure area. Then because it wants to balance it out, so when the air moves from lower pressure area to higher pressure area, okay, I'm saying like it's what I'm saying, it's the opposite of one. From the higher pressure area, it, it will it will want to lose its pressure because it wants equilibrium. That's why when the air in the higher pressure area, it once it goes to the low pressure area, like it will go to the low pressure area. This is also will want to go to low pressure area, but there might be some barriers. Let's read, let's get through this and then we'll get a clearer picture about this. The small difference in pressure are highly significant in terms of wind direction and the velocity. Horizontal distribution of pressure studied by drawing isobars at constant level. Isobars are the line connecting the place having the equal pressure in order to eliminate the effect of altitude on pressure. In the last chapter, we have studied isotherms. It's a line connecting the places which has equal temperature, and now again it is a line connecting the areas which has equal pressure, but this time it is called isobars. Now let's carry on. In order to eliminate the effect of altitude on effect of altitude on pressure. It is measured at any station after being reduced to sea level. Reduced to a sea level for purpose of comparison. So when we compare the pressure of two places, we compare it at a sea level. The sea level pressure distribution shows on the weather map. This is shown for the at the sea level. The pressure. This area has equal pressure. This line has equal pressure. Let's see around India. India has almost a pressure of 115, and yes, now 115 is higher, so the wind is moving in this direction, toward this direction, almost in circular motion. Okay. Yeah, this is much. This almost same. They show the pattern of isobar corresponding to the pressure system. Low pressure system is enclosed one low pressure system is enclosed by one or more isobars with the low pressure system is enclosed by one or more isobars with lowest pressure in the center. So the center has the lowest pressure, and around it will be surrounded by isobars of higher pressure, and it will also be surrounded by the isobars of the much higher than its center. So the middle part has lower isobar with lower pressure at the center. So low pressure system is enclosed one or more isobars with lowest pressure in the center. High pressure center is also enclosed by one or more isobars with highest pressure. So this one more. So high pressure system is also enclosed by one or more isobar with highest pressure in the center. Let's see where this it. This is the highest one. Now we get to learn this is 1000. Well, this I have not understood. This high pressure system is also enclosed by one or more isobar. I know the low pressure system is enclosed, but this one is low pressure, this one is a low pressure, this one is low pressure. Okay, let's see. Okay, this H1 is the higher one. Higher one is also enclosed in a low pressure. Okay. This one is higher and it's enclosed by a 15 one, but it is a much larger area. So high pressure. So this one is a high pressure. It is also enclosed by this one and this one, 225 and 220. Okay. So where is India? India is in comparatively 1015 ISO by one or more ISO with highest pressure in the center. Okay, so let's mark this with a green one. So I know that both the so world distribution at sea level pressure. The world distribution at sea level pressure in January and July has been shown in the figure 9.2 and 9.3. 9.2 and this is a July one. So oh, that's why it is attracting cyclones. See, India is basically a low pressure area. That's why the higher pressure area is the wind is coming from the higher pressure area. toward the lower pressure area. That's why we are almost cyclone every year. No wonder it is in the time of July to this time. What is the time? Today is like October, and we have one cyclone in Odisha right now. So let's see. The world distribution at a sea level pressure in January and July has been shown in an area near the equator at a sea level pressure is low. An area is known as equatorial low because the sea level because near the equator sea level pressure is low and the area is known as equatorial low. Now along the 30-degree north and 30-degree south found found a high pressure area known as subtropical highs. So again we have subtropical highs. Further poleward along the 60-degree north, 60 degree south. Let's see, 60 degree. This is a 90. We have somewhere 60 here, 60-degree here, and 60 degree. This is talking about this area. And a 30 and 30 is 130 is right. 0 to 30 and 30 from here is 60. 30 somewhere here maybe, yeah, or somewhere here. Zero 30, okay, 0 to 30 and somewhere over here also it is. So basically 30 north and 30 south, 30 north and 30 south, somewhere here is a low pressure area and somewhere here is a high pressure area. Uh, 30-degree found to be hot pressure for subtropical heights. Further poleward along 60-degree north and 60-degree south, the low pressure belt are termed as sub. This is known as the subpolar lows. Near the poles, the pressure is high, and it is known as polar high. Near the poles, the pressure is high. So near the poles, pressure is high. These pressure belts are not permanent in nature. They oscillate with the apparent movement of the sun. In the northern hemisphere, in winter, they move southward. In the summer, northward. So in the northern hemisphere, in winter, they move southward. So basically, in winter, northern to southern movement, and in summer from southern hemisphere to northern hemisphere. The force affecting the velocity and the direction of wind. You already know the air is set in motion due to difference in atmospheric pressure. Air in motion is called wind. The wind blown from the high pressure to low pressure, and wind at the surface experience friction. Wind at the surface experience friction due to dust particles and dust particles, gases, and many more, and everything that makes up the atmosphere. In addition, rotation of the Earth is also affects the wind motion or movement. The force exerted by the rotation of the Earth is called Coriolis. So now we got the proper definition. Now let's mark this with a green one. This is the definition and not a keyword. So we are marking definitions with the green one and a keyword with. Okay, there's one more keyword. They oscillate with apparent movement of the sun. Okay, these are the keywords. Like when we read it, when we read the keywords, we'll get a much clearer picture when we in the second or third reading. We'll get much clearer picture when we read through the keywords. Thus, the horizontal wind near the Earth's surface responds to combined effect of three forces. The first one is the pressure gradient force. The second is the frictional force, and the third is Coriolis force. So this is for the horizontal wind. The first is the pressure gradient force. The second is the frictional force. Combined effect of three forces. So combined effect is also a keyword. And Coriolis force. In addition, the gravitational force acts downwards. Now the first one, the pressure gradient force, the first one out of the combine of three forces. The difference in atmospheric pressure produces a force. So the difference in atmospheric pressure, so there is a difference in atmospheric pressure here and here. Okay, so this will produce a force. The rate of change of pressure with respect to distance. So rate of change of pressure with respect to distance. So what can I if I want to give it a rate of change per. So so we got, what is the pressure, barometer or millibar? Yes. So for pressure we are using millibar. So millibar per kilometer. If we are defining the rate of change of pressure with respect to distance, so we can also say that it is millibar per kilometer, right? It's a pressure gradient. It's the pressure gradient. The pressure gradient is strong when the isobars are close to each other, and is weak when the isobars are apart. So it depends upon the distance between the different isobars. If they are close, the gradient force will be much more. The pressure gradient force will be much higher. Let's take the second one, 1035. So less pressure, GRADI force. So the pressure is strong when the isobars are close to each other, and weak when the isobars are apart. So this is also, since this is a definition, let's go to the next one. Frictional force, it affects the speed of the wind. Greater the surface, it is greater at the surface, and it is influence generally it and its influence generally extends up to an elevation of 1 to 3 kilometers. Over the sea surface, sea surface friction is minimal, so there is not much dust particles in the sea, so that's why maybe the friction is minimal. So the effect of speed is the effect of speed of wind is our it affects the speed of wind. It is greatest at the surface, greatest at the surface, and its influence generally extend up to an elevation of 1 to 3 kilometers. From the surface, Coriolis force. The rotation of Earth about its axis affects the direction of the wind. Since imagine the let's make it a better one. Is at okay, there is a shape. Imagine this is Earth, and this is and imagine this is the atmosphere around the Earth. Okay, now the Earth is rotating in its axis. Now this is the axis. Earth is rotating, but the wind doesn't have its own, like it is not attached to the, it is not physically attached, right? It has some attachment. It is not physically attached to the Earth's surface, so there will be so since Earth is rotating, like imagine this way it is rotating, this way it is rotating. So when it rotates, since the atmosphere is here, in some time, like in for 1 hour, in 1 or 2 hours, the person who is here, he has reached this place, and due to the the air will be like, imagine in hypothetical the air is stationary, but for that person the air is moving because the Earth is rotating. So due to this force is applied on that person due to air, and he thinks the air is moving, but the air is at the same place, it is not moving at all. So this force which is applied on that person is called this Coriolis force. Very bad at pronunciation, so let's go about it. The axis affect the direction of the wind. The force is called Coriolis force after the French physicist who described it in 1814. So let's mark some keywords about the axis affect the direction of the wind. This force is worked out by the French physicist. It deflects the wind to the right direction in the northern hemisphere. So that's what it does to the wind. Let's study about it. It deflects the wind to the right direction. Deflect the wind to the right direction in the northern hemisphere, and to the left in the southern hemisphere. So due to this force, so this is the axis, this divided. This is our southern hemisphere. This is our northern hemisphere. So due to this force, the air is pushed to a northern hemisphere, and it is also pushed towards southern hemisphere. Not pushed, like it is deflected. It deflects the wind toward the right direction in the northern hemisphere and to the left in the southern hemisphere. The deflection is more when the wind velocity is high. So there is more deflection when the wind velocity is high. This is the keyword, deflects the wind to the right direction of the northern hemisphere. Okay. The Coriolis force is directly proportional to the angle of latitude. So Coriolis force is directly proportional. What is this? Directly proportional to the angle of latitude. It is maximum at the poles and absent maximum at the poles, and is absent at the equator. So that's why we have so much like wind in the polar regions. This is due to Coriolis force. Coriolis force acts perpendicular to the pressure gradient force. And the pressure gradient force is perpendicular to isobars. Okay, so it is saying, let's see. So it is saying, imagine this is now pressure gradient is between two layers, as we have read. So imagine this is the one. So our pressure gradient force will be acting in this way and in this way, perpendicular to this isobars. And now when we are forming a perpendicular, let's increase the size. Can we do it more? Let's go to 50. Okay. Now, as for that, Coriolis force is saying firstly the isobars. This is now the pressure gradient force is perpendicular to isobars. Okay. Now again it is saying that Coriolis force is perpendicular to this part and this part. It is perpendicular to that. So direction of force of Coriolis force is perpendicular to our pressure gradient force. So that direction, so the force is applied here. So force is applying here. So obviously it's going toward the poles, and the wind is also going toward the poles, and here also it is also since imagine this is the one. This is between two. This is a pressure gradient perpendicular to the isobar, and this is perpendicular to that pressure gradient force, our Coriolis force. Now due to this force direction, our wind is going in this direction also. Not not in this in this direction, but this is the wind direction. But ultimately it is going toward this. It is going toward this. It is going toward this. This is the direction of Coriolis force. This is the direction of Coriolis force. This is the direction of Coriolis force. Let's go back to 110. No, 150. This is much better. Coriolis force act perpendicular to the pressure gradient. For the pressure gradient perpendicular to pressure gradient, this is a definition, not a keyword. The pressure gradient is perpendicular to the isobars, and the pressure gradient is perpendicular to the isobars, to an isobar. Okay, higher the pressure gradient, the more is the higher the pressure gradient force, more is the velocity of the wind, and the larger is the direction, larger is the deflection in the direction of the wind. As a result, these two forces operate perpendicular to each other. The low pressure areas, the wind blows around it. In the low pressure areas, the wind goes around it. At the equator, the Coriolis force is zero at the equator, as we have already read here somewhere. So we have read it. The horizontal layer, the educational force. I guess duration layer. Okay, yes, this is caption at the equator. Equator, the Coriolis is zero, and the wind blows perpendicular to that isobar. Wind blows around it, equator, the Coriolis force is zero, and the wind blows perpendicular to the isobar. The low pressure areas, the low pressure get filled off. The low pressure get filled instead of getting intensified. That is the reason why tropical cyclones are not formed near the equators. The pressure and the wind. The velocity and the direction of the wind are the net result of the wind generating force. They are the velocity and the direction of the wind are the net result of the wind generating force. Okay, the wind in the upper atmosphere, that is 2 to 3 kilometers above the surface, are free from frictional effect of the surface and are controlled mainly by the pressure gradient and Coriolis force. So when we get questions like which forces are act on the upper atmosphere, so we'll say that the pressure gradient force and the Coriolis force is acted so let's know this is kind of a definition, like let's mark it with a yellow one. 2 to 3 kilometers above the surface are free from frictional effect of the surface and are controlled mainly by pressure gradient and Coriolis force. When the isobars are straight and when there is no friction, the pressure gradient force is balanced by the Coriolis force and the resultant wind blows parallel to isobars. The wind is known as the geostrophic wind. Geo blows parallel to isobar. When isobars there is no friction. When isobar and are straight, and there is no friction, the pressure gradient force is balanced like so. Goes parallel to the isobars. Okay. Yes, the correct explanation of this. So this is the Coriolis force and our pressure gradient is acting. So both are balancing it out, and when it is balancing it out, we get a wind which is parallel. As we know, the isotherms, the pressure gradient is perpendicular to the isotherms, and so our geostrophic wind is parallel to isobars. Okay, we get the gist of the Okay, let's go to the next one. The wind. Let's erase this. The wind circulation around a low is called cyclonic circulation. The wave circulation around a low is circulation around low. This is a keyword. Wave circulation around the low is called. This is the pattern. Okay, this is the pattern of the cyclone, and it is 9.2. Table number 9.2. Okay, let's see. Pressure shift cyclone or anticyclone. And so cyclone occurs at a low pressure area. The wind pattern is anti-clockwise. So anti-clockwise this direction. Anti-clockwise is in the northern hemisphere. Imagine this is. Let's make it a diagram itself. This is the Earth, and it is divided by a northern hemisphere, southern hemisphere. So cyclones occurs at the northern hemisphere. So, and the wind is also, the pressure is low here, and it is anti-clockwise, so this direction. And in the southern direction, and the cyclone also occurs at in southern direction. When the cyclone occurs, it goes at the, here it is cyclone in clockwise. The direction, like the circular motion of the cyclone is in clockwise in southern hemisphere. In the northern hemisphere it is in anti-clockwise. Okay, cyclone, basically cyclone. Oh, let's erase. And anticyclone is just opposite of all. So when anticyclone occurs, wow, I never heard of this anticyclone pressure system. So direct pattern of indirection southern hemisphere. The anti-direction is completely opposite. So basically anticyclone is in anticyclone the area is with high pressure. The center where the anticyclone occurs is a pressure of high pressure area at the center. Where the cyclone at the center of the cyclone is high pressure area, but here it is low pressure area. Let's go ahead. Okay, the direction of the wind around the system changes according to the location in a different hemisphere. Okay. The wind circulation at the Earth's surface around low and high. The wind circulation at the Earth's surface around low and high on many occasions is closely related to the wind circulation at the higher level. Okay, let's read it once again. I am not getting what it's trying to say. The wind circulation at the surface of area around low and high, okay, on many occasions is closely related to wind circulating at higher level. It's closely related to wind circulating at higher level. This is a keyword. Higher level means in higher altitude. Okay, generally low pressure area, the air will converge and rise in the low pressure area. Over the high pressure area, air will subdued from the above and diverge at the surface. So in the okay, so imagine this is a high pressure area. So from the high pressure, due to physics, the wind will go in this direction, and when it goes in this direction, it will go to the low pressure area, because from high pressure to low pressure area wind travels. And due to high pressure area, subdue and divert from the surface. Apart from the convergence of medium convection current, which organic uplift along cause the air to rise, potentially form the clouds. Okay, this is due to this. When it is going, it is also carrying some water vapor and some molecules with it, which will eventually form clouds, and it will cause rain. And this process here, it is divergent and it is convergent. Yes, divergent and convergent. Okay. Let's let's read it and I'll explain it once again. Let's see. Generally, over low pressure area, air will converge and rise. So generally in low pressure area, over low pressure area, the air will converge. Low pressure area, air will come in this direction. Okay, this is low pressure area. The pressure air will converge. So when it converges, so and it will rise. After getting mixed up, it will rise. So it will rise above. It will rise, and over the high pressure area, air will subdue from above. So in the high pressure area, this is the, let's imagine this is high. Air will subside since it is going outside. So it is going outside. Subside from above. Okay, this is going subside from above. Imagine this is a high altitude also. It will subside from and diverge at the surface. Okay, the low and the high at low pressure area and high pressure area. Low pressure area is high pressure area, it will subside and it will diverge at the surface. So it will go down and it will go and diverge. But divergence means it's getting apart. Yeah. Let's read it once again. Generally, over low pressure area, the air will converge and rise. The air will converge. So the air is coming. It is coming here and it is converging. CONVERGE, converging, and it is rising up in a low pressure area. Whereas in the high pressure area, the air will subside from the above and diverge and from above. So in the high pressure area, the air is okay. Wait. The thing is, I'm doing it wrong. Somewhere I did wrong. Yes, I got it. Basically, low is here because due to low pressure means that is it's already at some altitude. Low atmosphere, low pressure layer. So sorry, pressure. PRESSUR, low pressure. So basically, and high pressure will be at much lower altitude. So here what is happening, it is saying that the high pressure area air will subside from above. It will subside from above, subside from above and diverge at the surface. From above, subside from above. High pressure area, the air will subside from above and diverge at the surface. So in the high pressure area, okay, it is converging here and subsiding. This is much easier, but I'm not going through the diagram. That's why I'm trying to explain it on my own. So we have this to the surface. This area is the surface area. Okay, surface, and this is the high pressure area and low pressure area. Different surface has different isobars and different air pressure. That's why imagine this has uh, lower isobar. This place has lower pressure. That's why low pressure. This is 135 and this is 1000. And now what is trying to say, at the high at the high pressure area, the what is air, that is air for yes, air is converges at the top, like at higher altitude it converges like it combines, and it diverges at as soon as it goes to the this high pressure area. It diverges, like it splits. Basically the air splits, and it goes to the low pressure area, and it goes like as a wind, it goes to the low pressure area as the air goes from higher to lower pressure. And when it goes to a lower pressure area, again it converges. And when it converges, and due to some forces like due to heat and all, the air rises above, and when it goes to certain altitude, again it diverges. So basically at higher altitude, at a higher pressure area, at the surface level, the air that it splits, that is a divergence, that it diverges, and at the same higher pressure area at some altitude it converges. So it combines at altitude, and it diverges, like differentiates at the surface, below surface. Let's write this down. At much simpler term, like high pressure, what happens at surface, what happens, divergence. And also at altitude, what happens? It converges, and basically low pressure area, it converges at surface. GES converges and diverges. Oh, this took a lot of time to explain, like from not explain to for me to understand. Let's moving along. General circulation of the atmosphere. The pattern of the general circulation of the atmosphere. The pattern of the planetary wind largely depends on the. Okay, this is the keyword. Largely depends on the latitudinal variation of the atmospheric regime, emergence of pressure belt, and third is migration of the belt following the apparent part of the sun. We have read this before. Distribution of the continent and the ocean. This is also important. Rotation of Earth. Coriolis force. That is the pattern of the movement of the planet wind is called general circulation of the atmosphere. The pattern of the movement of the planetary wind. Okay. General circulation of the atmosphere. Okay, this is not. Uh, this is basically a keyword. General circulation. Okay, so sorry. General circulation. The general circulation of the atmosphere get also set in motion in the ocean water circulation, which influences the Earth climate. And a schematic description of the general circulation is shown in 9.6. So this is the general circulation of the wind. Okay. This is the equator, and the wind is southeastern trades. Here the water lies here. Some water also lies here, and here somewhere here is India. The polar vortex. So polar vortex and south pole. Polar cell. This is south pole. Polar jet. Well, let's read about it. We'll get a much clearer vision of it. The air at the intertropical convergence zone. Intertropical convergence zone. Intertropical convergence zone. The air rises because of convection caused by the high isolation and low pressure, and a low pressure is created. So here this air, and we know that at the equator the isolation is most at the equator. So that's why due to isolation convection happens, convection, and due to convection the air gets heated up and it goes and it rises, and due to this rise low pressure is created. When low pressure is created, the wind from the tropic converges with this low pressure zone, and the converged air rise along with the convective cell. This convective cell, let's see, where is the convective cell? Pedal cell, we don't see convective cell. Okay, it is polar cell, polar jet stream, pedal cell, tropical jet stream, hardel cell. The converged air rise along with the convective. It reaches the top of the troposphere. It is just the top of the troposphere at an altitude of 14 kilometers, and they move toward the poles. So this is moving toward the pole. Okay, this is moving toward the pole. This is moving toward the pole. This is no, this is not. This is going toward the 30-degree. So these are basically our this first one, not the fourth one, the one nearer to the poles. like this one, and move toward the pole. And this, okay, this is 130 degrees south, 30 degrees south. Moves and 30 degree north and 30 degree north and south. Degree north and south. The part of the accumulated air sinks to the ground and form a subtropical high. Another reason for the sinking of the cooling of air when reaches a 30 degree north and south altitude. Down below the surface, the air moves toward the equator at the earliest. The the eastern lies eastern as the eastern lies. Okay, it is eastern lies. The eastern lies from this toward the equator as eastern lies. This is a keyword. Subtropical high is a keyword. Forms a subtropical optical high. Down below, okay, the eastern lies from the either side. Eastern lies from the western lies. Eastern lies will be in this side. This is western lies, western lies, western lies, eastern lies. So eastern lies from either side of the equator, that is from either side of the equator forms converges. So either side of the equator, the eastern lies converges to form the this this the one at the equator, that is intercontinental convergence zone, where all the air converges. Well, all the air from the eastern lies converges. Such circulation from the surface upward and vice versa is called cell. So the cell in the tropics is called Hartley cell. So where the tropics are, this is Hartley is basically tropics are basically at the equator. That's why the Hartley cell is at the equator. Now one more is Ferrel cell. Let's see where the area comes under the in the middle of the latitude. The circulation is of the sinking cold air coming from the poles and the rising warm air that blows from the subtropical highs. And at the surface, these winds are called westerlies. Westerlies. So down below near the area where air flows toward the equator. So easterlies are the areas from where the air below flows toward the surface air that blows toward flows toward the equator is easterlies, and uh, the warm air that comes from in the middle of the latitudinal circulation of sinking moon and poles and the rising of warm air that blows from the subtropical highs. These areas, yes, the warm air that blows from the subtropical highs, the surface where these winds are formed are called westerlies, and the cell is known as Ferrel cell. So the eastern lies is Hartley cell, and this is the subtropical from the western lies, and this is Paul. These are the eastern lies, and so eastern lies forms. It goes toward the equator, and it forms Hartley cell, and the subtropical one, the polar wind that comes from the uh, polar region. It mixes with the western lies. Okay, at a polar latitude, the cold dense air subsides near the poles and blows toward the middle latitude as the polar eastern lies. This cell is called polar cell. Okay. So I got confused. The eastern lies is here itself. This area is our polar eastern lies, not eastern lies. So I got confused. Sorry. This is okay. These three cells set a pattern for the general circulation of the atmosphere. The transfer of heat from lower latitude to higher altitude maintains the general circulation. So transfer heat from lower latitude to higher latitude. Transfer of heat is a keyword. Transfer of heat from lower latitude to higher latitude maintains general circulation. General circulation of the atmosphere also affect the ocean. The large-scale wind of the atmosphere initiate large and slow movement of the current of the ocean. So ocean in turn provides input of energy and water vapor into the air. These interactions take place rather slow over a large part of area. General atmospheric circulation and its effect on ocean. The warm and the cooling of Pacific Ocean is the most important in terms of general atmospheric circulation. So this is most important. So I'm going to mark all of this. Is the most important in terms of atmospheric circulation. The warm air of the central Pacific Ocean slowly drifts toward the South America coast and replaces the cold Peruvian current such current. Such appearance of warm water off the coast of Peru is known as El Nino. Okay, this year we suffered El Nino effects. This is 2025, and this year we suffered the most El Nino effect. Most of El Nino effect is due to which we will suffer more cooler like will the temperature will be much lower this year, like all year around. Will not get much summer heat, and we didn't got much summer heat this year, and the summer was not much harsh this year. And okay, yeah, the El Nino, and the El Nino event is closely associated with the pressure change in the Central Pacific and Australia. This change in pressure condition over the Pacific is known as the sudden oscillation. Let's mark all of this. The change in pressure and condition, okay, with sudden oscillation. The combined phenomena of the sudden oscillation and the El Nino is known as ENSO. ENSO. In the year when the ENSO is strong, large-scale variation of weather occurs over the world, and the water-arid west coast of South Hemisphere receive heavy rainfall, drought, and sometimes in Australia, and sometimes in India, and the flood in China. This phenomenon is closely monitored and is used for long-range forecasting in major part of the world. So now next is the seasonal wind. Seasonal wind. The pattern of wind circulation modified in different seasons due to shifting of region of maximum heating pressure. So we got that the keywords are circulation is modified in different season. Modified in different season is a shift in the region of maximum heat. The shifting in the region also a keyword, shifting of region of maximum heat pressure and wind belt. The most pronounced effect of the shift is noticed in monsoon. Most pronounced effect. This is also clear on this. Monsoon, especially over the Southeast Asia. You would be studying the detail of monsoon in the book of India Physical Environment in CRE 2006. Okay. The other local deviation is general circulation as follows. The local wind difference in the heating and cooling of Earth's surface. Difference in heating and the cooling of Earth's surface. The cycle of those develop daily or annual, and the cycle those develop daily or annual can create several common local and regional wind. So this is basically due to this is local wind. This is for some reasons like for India, Australia. It is always different for every region. Okay, let's annually create several common can create several common locality. Okay, those cycles are less cooling of earth and heating and cooling of earth. Basically, this is the keyword for this one. And surface of earth and cycle those develop daily and annual can be a keyword. Land and sea breeze. Okay, this is much easier. As explained earlier, land and the sea absorb and transfer heat differently. During the day, the land heats up fast and becomes warmer than the sea. Therefore, over the land, the air rises and the air rises giving rise to low pressure area. So during the daytime, the surface, the land, where the land is, it is a low pressure area, whereas sea is relatively cooler, and the pressure of the sea is relatively high. So the wind, so that's why the wind, as the wind blows from the high pressure area to low pressure area, that's why we feel sea breeze, because the breeze is coming from the sea. Thus, the pressure gradient thus the pressure gradient from sea to land creates a wind blow from sea to land is known as the sea breeze. In the night, the reverse is happening, because the water takes a lot of time to get heat up, and it has a like it's and it takes a lot of time to lose heat also. So uh, that's why the land cools much faster at the night, and the sea stays relatively heated up. Due to this, the sea suffers a land breeze. So over the sea there is low pressure area in the night time, and in the night time also the same. The land has high pressure area. So the wind blows from high pressure to low pressure area. The the breeze goes from the air goes basically air the wind goes from land to sea, and it is known as the land breeze. Mountain and valleys wind. In the mountain region during the day, slope gets heated up and the air moves up slope. And to fill the resulting gap, the air from the valley blows up the valley. The so so mountain region. So basically, in the valley, the air from the valleys goes up toward the mountains, and this wind is known as mountain wind, valley breeze. I'm so sorry. And during the night time, the slope gets cooler, so there is much high pressure area. That is, the mountains are the high pressure area, and a dense air descend toward the valley. So due to high pressure, the air is much denser in the high pressure area. So what it does, due to gravity, it goes down the valley, and it is known as the mountain wind. The cool air of the high plateau and ice field draining the valley is called Kabatic wind. Okay, this is something. The cool air of the high plateau and the ice field draining into the valley is called Kabatic wind. Another type of warm wind occurs on the leeward side of the ranges. The moisture in this wind, while crossing the mountain ranges, condenses and precipitates. When it descends down the leeward side of the slope, the air gets warmed up by a, uh, adiabatic adi, adi, adiabatic adia, adiabatic adiabatic process. This dry air may melt the snow in short time. Okay, let's see what is happening here. The leeward side of the slope. The side of the slope, dry air gets warmed up by adia, adiabatic force. No, adiabatic process. Moisture in this one. Okay, let's move to the next one. How much we have left? We have more 3 pages. Wow. No, in fact, 4 pages. 3.5. Hmm. When the air remains over a large homogeneous area, for a sufficiently long time, it acquires the characteristics of the area. The homogeneous region can be a vast ocean surface or the vast plains. The air with the extensive characteristics in terms of temperature and humidity is called air mass. So it is defined as a large body of air having defined as a large body of air having little horizontal variation horizontal variation in temperature and moisture. This is a definition. Let's mark it as a definition. Large body of having little horizontal variation in temperature and moisture. The homogeneous surface over the homogeneous surface over which this air mass is from called the source region. The air masses are classified according to the source region. There are five major source regions. These are so okay. The air mass is classified according to the source region. So we have, let's see the source region. The first source region is a warm tropical and subtropical ocean. Now, and the second is subtropical hot desert. The next one is the relative cold, the relatively the relatively cold high altitude ocean. The next one is very cold snow covered continent. Very snow covered continent in high latitude. The, la- the last one is permanently ice covered continents in the Arctic and the Antarctica. According Accordingly, following types of air masses are recognized. Bless me. Maritime tropical. The first is maritime tropical. Maritime tropical, continental tropical, maritime polar, MP, CP, MP, continental polar, CP, continental Arctic, tropical air mass. Okay, tropical Arctic. Okay, tropical air masses are warm, polar air masses are cold. Wow. Fronts. When two different air masses meet, the boundary between them is called front. The process of formation of the front is known as frontogenesis. There can be four types of front. For this first is cold, warm, stationary, occluded. Okay, when the front remains stationary, it is called stationary front. When the cold air moves toward the warm air, toward the warm air mass, the contact zone is called cold front. Whereas if the warm air mass moves toward the cold mass, the contact zone is called warm front. If the air mass is fully lifted above the land surface, it is called if an air mass is fully lifted above the land surface, it is called occluded front. The front occurs in the middle latitude and are characterized occurs in the middle latitude and are characterized by steep gradient in temperature and pressure. Are characterized in occur in middle latitude. Front occurs in middle latitudes and are characterized by steep gradient in temperature and pressure. They bring abrupt changes in temperature and cause the air to rise to form cloud and precipitation. So the front causes air to rise, forms cloud and cause precipitation. Extratropical cyclone. The system developing in the mid and high latitude. The system developing in the mid and high latitude beyond the tropics are called extratropical cyclone. The system developing in the mid and high latitude. The passage of the front, that is, patches of the front, cause abrupt change in the weather condition over the area in the middle of in the middle of in the middle and high latitude. In the middle, okay. Extra tropical cyclone forms along the polar front. So it is formed toward the polar front. Initially, the front is stationary. In the northern hemisphere, the warm air blows from the south, and the cold air blows from the north of the front. When the pressure drops along the front, the warm air moves northward, and the cold air moves towards south, setting in motion an anti-clockwise cyclonic circulation. The cyclonic circulation leads to a well-developed extratropical cyclone. With a warm front and a cold front, the plane and the cross-section of the well-developed cyclone is given in this thing, 9.9 extra. Okay, this is our, let's see from the beginning what is happening. Okay, it's A and B. Cold air is going below the warm air because it is much denser, and what it does, it spins direction of motion. This is the center of direction of motion in the center. So it makes the cold air and the warm air, cold gas inside, like below the warm air. Okay. There is a pocket of warm air and sector wedged between the front and the rear cold air or the cold sector. The warm air glides over the cold air, and a sequence of cloud appears over the sky ahead of the warm front and causes precipitation. The cold front approaches the warm air from the behind and pushes the warm air up. As a result, cumulus clouds develop along the cold front. The cold front moves faster than the warm front, ultimately overtaking the warm front. The warm air is completely filled up, and the front is occluded. And the cyclone dissipates. So basically it is saying that when the cold air completely overtakes the warm air, the process of cyclone stops. So until and unless the cold front doesn't overtake the warm front, we have cyclone. The process of wind circulation both at the surface and asoft are closely interlinked. The extra-tropical cyclone differs from the tropical cyclone in number of ways. The extra-tropical cyclone has a clear frontal system, which is not present in the tropical. So we are saying that extra-tropical cyclone has a clear frontal system. And which our common basic cyclone doesn't have. They cover a large area and can originate over the land and the sea, where the tropical cyclone originates only over the sea and reaches on the land they dissipates. And on reaching on the land it dissipates. The extratropical cyclone affects a much larger area as compared to the tropical cyclones. The wind velocity in a tropical cyclone is much higher and it is much more destructive. So So tropical cyclone is much more disruptive, but extra tropical cyclone move from the west to the east, basically in this direction. Move toward the from the west to east. Okay, but a tropical cyclone moved east from east to west. So let's try it one more time. It moved from west. Less destructive. The extratropical cyclone moved from west, but tropical moved from east to west, and it is also anti-clockwise. Yes, somewhere I read this is an anti-clockwise and moves around. Okay, the cyclonic circulation is okay. Now anti-clockwise cyclonic circulation. Okay, anticyclone. I want to read about the anticyclone. How this is different from the anticyclone. Because the anticyclone is also anti-clockwise. Let's see. Now anticyclone is also yes. Anticyclone is anti-clockwise. Okay, the anti-clockwise in southern hemisphere. Anti-clockwise. Okay. Yes. Most of the age. Okay, now we have much violent. This is not extra tropical. This is tropical cyclone. The tropical cyclones are much violent storms that originate from sea in tropical areas, over the ocean in tropical areas, and move toward the coastal areas, bringing about a large scale of destruction. Large scale destruction caused by violent wind, heavy rainfall, storm surges. This is one of the most devastating natural calamities. Devastating, most one of the most. It's not most. They are also known as cyclones. And this is a keyword. No, this is not a keyword. This is also known as cyclones in Indian Ocean. Hurricanes in Atlantic and typhoon in Western Pacific and Southern China Sea. And Willy Willies. Wow. This is hilarious. Willy Willies. Okay. So tropical cyclone originate and intensify over warm tropical ocean. The conditions favorable for the formation and intensification of the tropical storm are large area, surface, uh, large sea surface with temperature higher than 27 degrees Celsius, presence of Coriolis force, small variation in vertical wind speed, a pre-existing low pressure area or low level cyclonic circulation, upper divergence upper divergence like dissipation at the upper level. The energy that intensifies the storm comes from the condensation process in the cumulon cumulonimbus culu culu what's that cumulonimbus cumulonimbus clouds surrounding the center of the storm. With the continuous supply of moisture from the sea, the storm is further strengthened. From reaching the land, this moisture supply is cut and the storm dissipates. The place where the tropical cyclone crosses the coast is called land of cyclone. And these are all Moisture from the sea is okay. The continuous supply of moisture from the sea is the main reason for this destructive power. And on reaching the land, the moisture supply is cut off. Storm dissipates. The place where tropical cyclone goes is the land of cyclone. The cyclone which crosses 20 north latitude generally recurves and they are more destructive. Okay, okay. Which crosses 20-degree latitude generally recurves and are more destructive. That's schematic representation of the vertical structure of the major tropical cyclone is shown in 9.10. So let's see whether this is a troposphere, okay, undisturbed wind. This is the direction of the storm, and this is it is anti-clockwise. So it is in this cyclone is anti-clockwise. Let's see what is given about the cyclone that is anti-clockwise. Cyclone which is anti-clockwise, so this cyclone has occurred in northern hemisphere. Since this has occurred in northern hemisphere, let's see something more. And pressure condition so the pressure condition at the center is low. Okay, all the cyclone has lower pressure at the center. Only anticyclone has high pressure. So this is the eye wall. The outflow, the air goes outside from this channel. The rain band. The rain is also going outside from this channel. The rain band. The steering force. Subsiding warm air. So warm air is going at the inside, and from the warm subsiding warm air, the one going is not inside. It is going directly at the eye, and from the eye it forms two channels. One from where the water goes out. This is rain band. Vertical section of tropical. Okay. Understood. Okay. A major tropical cyclone is characterized by strong spiral circulation. A major cyclone characterized by strong spirally circulating wind around the center is called the eye. Diameter of the system can vary from circulating system, like the whole thing, like the whole circulating thing. This distance, the whole thing is 150 to 250 kilometers. The eye is a region of calm with subsiding air. So whenever there is a hurricane, try to stay at the middle, at the eye. Around the eye is the eye wall where the air is, where the where where there is a strong spiraling of ascent of air. Ascent means going at the top, like it's going vertically upward, not directly upward, directly vertically, like it is basically rising upward. Air is greater at the height. Ascent of air is greater at the height, reaching the troposphere. Is plotting where the at the eye, the center where there is strong spiraling of ascent of air, the air which is going upward to greater heights. So air is pushed upward from the eye wall, reaching the troposphere. topos, the area between the stratosphere and the troposphere. Okay, the wind reaches maximum velocity in the region. In this region, the reaching as high as 250 kilometers per hour. Kilometer. The torrential rain occurs here. Torrential rain is also occurs here. On the eye wall, rain band may radiate and drains to cumulus and cumulon cumulonimbus cloud may into the outer region. Drift to the outer region. The diameter of the storm over the Bay of Bengal and the Arabian Sea and the Indian Ocean. The diameter of the storm of the diameter of the storm of the Bay of Bengal, Arabian Sea, and Indian Ocean is 601,200 kilometers. The moves slowly at about system moves slowly at 305 kilometers per day. This is slow. This is a slow movement. Like a common person who is traveling with a bike is going at this, make this much distance per day. The cyclone creates storm surges and they inundates the coastal lowland. The coastal lowland surges and they inundates the coastal lowland. The storm pressure out on the land. Like it dies on the land. The thunderstorm and the tornado. Other several local storms are called thunderstorms and tornadoes. They are short duration, occurring at a very small area but very violent. Small area but very violent. Thunderstorms are caused by intense convection convection on moist hot day. Intense convection. So let's mark it with a green one. So it is a small area but very violent convection on moist. The thunderstorm is well known cumulonimbus. Coulon Cumulonimbus. Cumulonimbus. This is very cumulon cum cumulon cumulonimbus clouds producing thunder and lightning. Okay, cumulonimbus clouds producing thunder and lightning. Lightning and when the cloud extend to the height where the sub-zero temperature fuels hails are formed and they come down as hailstorm. If there is insufficient moisture, a thunderstorm can generate dust storm. Thunderstorm is characterized by intense updraft of rising. Thunderstorm is characterized by intense updraft of air which cause the cloud to go big and rise to greater height. This causes precipitation. Later on, downdraft brings down the earth down to the earth the cool air and the rain. From several thunderstorms sometimes spiral into wind, called the trunk of an elephant with great force with low pressure at the center, causing a massive destruction on the way. This phenomenon is known as the tornado. So this is a low pressure at the center, causes massive destruction on its way. Spiraling wind descent, sometimes spiraling wind descends like a trunk of an elephant with great force, with very low pressure. And the tornadoes generally occurs in the middle latitude. And the tornadoes over the sea is called waterspout. Wow, this is a very nice one. And I love to see the one. The violent storm are manifestation of the Earth's the violent storm are the manifestation of the atmospheric adjustment to the varying energy distribution. The potential thunderstorm are the manifestation of atmospheric adjustment to varying energy distribution. The potential and the heat energy are converted into kinetic energy in this storm. Okay, converted. This is very good one. This is very good one. This is a very important one. These storms and the restless atmosphere again returns to its stable state. So the if the surface air pressure is 100,000 MPa, the air pressure will resume at 1 kilometer above the 1 kilometer, if the surface is 1000. So we have read that at 10 meters approximately how much is lost, how much pressure is lost. Almost 1 MB for 10 meters, so 1000. So 1 kilometer, as that is divided by 10 meters, 1000, that is 10 meter 100. So 100 is lost, so it is 900. The intertropical convergence. Intertropical convergence zone is normally occurs. Intertropical convergence zone. So it is an intertropical convergence zone. It normally occurs at the equator. Tropical near the equator. The direction of the wind around the low pressure, direction of the low pressure in the northern hemisphere is anti-clockwise. And low pressure in northern hemisphere. This is saying about the cyclone. The direction of the wind around the low pressure anti-clockwise. Yes. Let's go to cyclone direction in the in the low in the enclosure in the which one of the following is the source region for the formation of air masses? Man, which one of the following is the source region for formation of air masses? See, air masses can be formed in any areas. Like it has. Deccan Plateau is a good one. Siberian place, Himalaya no, equatorial forest no, Siberian plains also, but this is much more accurate. The unit measured in the pressure is isobar. No, this is millibar. Millibar. Am I right? Not millibar. Something milli something. So atmospheric pressure is measured in millibar. No, I was correct. The unit measured for measuring pressure is millibar. The pressure is measured at the station level at the reduced pressure level. Why is pressure measured at the station level reduced to the sea level in preparation of weather map? Because different altitude has different pressure. That's why. And yes, while the pressure gradient force is from north to south, from the subtropical high pressure to the subtropical high pressure to equator in the northern hemisphere. Why the wind? Why are the wind not easterly in the tropics? Why are the wind not easterlies in the tropics? We'll read this. Not done. Not CLEL. Watch video. Geostrophic wind. We have done this. Explain the land and sea. This is very easy. Discuss the factor affecting the speed and direction of the wind. Speed of the wind is caused by there are basically three factors. One is the pressure gradient force. Another is the Corli, Coriolis Coriolis force. Coriolis force. Coriolis force, and this one is the friction. The friction between the air friction is the third one. Draw a similar as the rating general circulation of the okay. These can be done where like these can directly copy it from the actual material of the chapters.